Hello everyone, so this is my first time to using the screen record software to doing my presentation. So there may have some noisy during my presentation time. So let's start my presentation. Course Assessment Task 1 by James Zhao. Let's talk about atomic radius first. The definition is the total distance from an atom's nucleus to the valence electron. And what is valence electron? The valence electron is the outermost orbital of the electron. But in diagram, you can see the two red electrons. So that is the valence electron. So before we talk about the periodical tree, we need to know two things. One is effective nuclear charge. Means net positive charge pulling this electron towards the nucleus, which means the attraction between the nucleus and the electron. And the second thing is the electron shelling, the blocking of a valence shell electron attraction by nucleus due to the inner shell electron, which means the repulsion between the inner and outer electrons. So for a periodical treat, in a diagram you can see the atomic radius is increasing by right to left and also increasing by up to down. For compare example, I choose the sodium and magnesium. So because the magnesium has more proton than the sodium, so it has bigger effective nuclear charge, which makes the outer electron more closer to the nucleus. So the magnesium's atomic radius is smaller than the sodium's atomic radius. And the second is compare between the sodium atom and sodium ion. The sodium atom has two electron shelling, but sodium ion only has one. And sodium atom has three orbitals, but sodium ion only has two. So the sodium atom has larger radius. And for ionization energy, the definition is the energy necessary to remove an electron from neutral atom. So in a diagram, you can see that higher ionization energy happens in the noble gas because it has the most stable states. So when we lose one electron, it means to change the stable state to the active states. So it needs much energy as possible to break the stable states. Okay, so the noble gas has the higher ionization energy. So periodical rate of ionization energy is increased by down to up and left to right. So for example of the first ionization energy, the lithium has one electron shelling and fluorine also has one electron shelling, but the fluorine has more proton than the lithium, so which means fluorine's atomic radius are more smaller than lithium, and which means the outer electron is more close to the nucleus, so it has bigger attraction. So fluorine has a bigger ionization energy to the lithium. And let's compare the sodium and the lithium. So because the electron shelling lithium has one, but sodium has two. So sodium has bigger repulsion between the inner and outer electron. So lithium has bigger first ionization energy because it's more difficult to remove the valence electron in lithium. For lithium. Okay, so electron affinity. So in diagram you can see the hydrogen has bigger electron affinity. So the definition for electron affinity is the change in energy of a neutral atom when the electron is added to form a negative ion. So in general term, the non-metal has bigger electron affinity than the metal, especially the hydrogen, because follow the octet rule, it has 7 valence electron and we want to become 8. So this means to active state to the stable state. So it needs a big energy change during this process. And for a periodical treat, it's increased by down to up and also increased to left to right. So for example, the lithium and the fluorine, their electron shielding are both 1. But fluorine has bigger than the electron affinity because it's also fluorine is easy to become the noble gas state. Will have 8 valence electron. It's more easy to have 8 valence electron than the lithium. So the fluorine has bigger electron affinity. Okay, let's compare lithium and sodium. The lithium electron shielding has 1, but sodium has 2, which means sodium has more repulsion, but lithium has less repulsion. So the lithium has a bigger electron affinity. I'm right? Yes, I can. Okay, so thank you for listening.